Number 49. We have a sphere and a cube. We know the side length of the cube is 0.931, and we know the surface area of the sphere is equal to the surface area of the cube. So let's see, what surface area formulas do we know? So for a cube is just 6 squares. The surface area is just 6 squares. So the surface area of the cube will just be 6 times the edge length squared, or 6 times 0.931 squared. Now, for the sphere, the surface area of a sphere is 4 pi r squared. And if we can find the radius, then we can also find the diameter, and that's this length. And then we can add it to 0.931, and that'll tell us this distance right here. That'll tell us what we're looking for. So we just have to set up an equation. Well, it tells us here that the surface area of the sphere is equal to the surface area of the cube, so this is a pretty straightforward equation. So I'm going to get the solver ready. So the cube surface area is 6 times the side length squared, and then the surface area of the sphere is 4 pi times the radius squared. So we get a radius, we'll ignore the negative value, we get a radius of 0.6433, which means the diameter is going to be double that, which is like 1.286. So we know this length right here is 1.286. So now if we want to find this distance with the question mark, all we have to do is take that value and add it to 0.931. So 1.286 plus 0.931, rounding to 2 sig figs, we get 2.22. So 2.22. All right, so that's that. Let's move on to number 50. So we have hemispheres. So these two hemispheres on the top and bottom, and we have a cylinder. And it tells us that the volume of the cylinder is equal to the volume of both the hemispheres. So let's see. Volume of a cylinder. Volume. This isn't working for some reason. Volume of a cylinder is equal to pi times the radius squared times the height. And the volume of a hemisphere is equal to 2/3 pi times the radius cubed. So if we have this equation, the volume of the cylinder is equal to the volume of both hemispheres. We just have to find out how we can get these different values. So the volume of the cylinder, we get pi. Do we know the radius of the cylinder? Yes, we do know the radius of the cylinder, because if the radius of your hemisphere is 0.0412, and it's lined up here, so you have the circles attached, then we also know that that's the radius of the cylinder. So we have pi times 0.0412 squared. And then do we know the height? Does not look like we know the height, but if we call this length, or actually no, I'm just going to make the height our variable. So pi times 0.0412 squared times the height, that equals 2/3 pi, and then we know the radius is 0.0412, and then cube that. But we're missing something because it says the volume of the cylinder equals the volume of both hemispheres. So we actually have to take this value on the right and multiply it by 2. So if I put this in a solver, we can actually solve for the height of our cylinder. So we have pi times, I already forgot the radius, dang it, 0.0412 squared times the height, not divided by the height, times the height, equals 4/3 times pi times the radius cubed. So let's do this, solve for h. We get a height of 0.0549, and then with a bunch of 3's. So we have the height, but what are they really asking for? So they want to know this total distance. So it looks like that's going to be the height plus 2 radii. So 1 radii up here, and another radii down here. So we just take our value of like whatever it was, 0.05, and then add 2 times the radius, 2 times 0.0412. 0.0412, and then take this round to 3 sig figs, we get 0.137. 0.137. So if you have any questions from other tests, make sure to leave a comment and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.